Hey guys, today we are talking about enthalpy. That might be a new word to some of you. A few of you may remember it from last class when we studied exothermic and endothermic reactions because we did use it in that discussion, but we're going to define it a little bit better today. It is the heat content of a system, and it's represented by the symbol delta H here, okay? So this symbol we saw on our diagrams last time. If you remember, I'll draw one here, but you don't need to draw one. If you remember, we had these drawings that looked like this, and the distance between the top and bottom, that had a little delta H on there. That is the same thing that we see here, and it is based on change. So this delta here, that is change. It's a universal symbol for that. It's used for lots of different things, but that's a change in H, a change in the heat energy that this has got. So sometimes in a reaction that change is positive and sometimes it's negative, depending on what happens with the energy. But enthalpy also applies to compounds, not just reactions themselves. And that's one of the things that we're looking today. It says every compound has a value called the enthalpy of formation. Formation here meaning your compound being created. So the enthalpy of formation is very specifically the amount of heat that's required to create exactly 1 mole of that compound. And the values for that, you never have to memorize. They're also not on the periodic table. They're usually given in a table. If you look down here on your notes, you've got a table for the different enthalpies of formation there. Okay, so that's for compounds. Pure substances, which shows are made of only one element, they have an enthalpy value of 0. And that's because they don't have any bonds. They are not attached to anything else. They're not compounds. So that enthalpy of formation for them is 0 because they don't have to be formed. They just already kind of are. So in order to calculate the change in enthalpy of the reaction, you're going to use this formula that you see here. And it says that the delta H is equal to the enthalpy of formation of the products, all the things that are going to be produced in a reaction, minus the enthalpy of formation for the reactants. So we're going to take that enthalpy in the end that we get with the products and subtract from it the enthalpy that was there in the reactants. If that value, that subtraction, ends up positive, that means our energy level went up. So energy had to be absorbed. And we learned last class that if energy is absorbed, the reaction is endothermic. If it goes up, that is endothermic. If it goes down, if delta H is negative, then that means your reaction is going to be exothermic. So today we're going to work on calculating those enthalpies of formations, seeing that change in enthalpy between the products and the reactants, and then classifying a reaction to see if it's endothermic and exothermic. All right, so an example down here says, what is the enthalpy of the following reaction? And we've got this table here that's got several different compounds. We've got CH4, O2, CO2, and H2O. Plus, over here we have the enthalpy of formation for each of those things. You can see those are all negative numbers. Now, one of the things that's going to be a little bit tricky when we're going about the math here is dealing with those negatives. So you're going to need to make really sure that you're keeping track of all your negatives along the way. You got to be pretty cognizant of that. So what we're going to look at first is our products and reactants. Now, hopefully by now you guys all know what products and reactants are, but just in case you don't, over here on the left, we've got the reactants. These are the things that are going to react together. And then we've also got the products on this side. These are the things that are created in our reaction. So we've got a reactants side and we've got a products side. So in our equation that we kind of defined earlier, we're going to say that our change in enthalpy here, which I'm going to highlight, that is equal to the difference in our products and our reactants. So I'm going to get a color for each of those things. Products, I'm going to make green. Okay, so these are the products over here. And the reactants, I'm going to make blue. You don't have to color code because you probably don't have all these pretty colors, but I'm going to so you can see it a little bit better. Okay, so over here in the products, I'm just going to write down what my products are. My products are 1 CO2. I'm going to put a multiplication symbol here. I've got 1 CO2 there and 2 H2Os. That's what I've got in my product. So we're making 1 mole of CO2 and 2 moles of H2O. And then the reactants that were used to create that come from that left side of the equation. I've got 1 mole of CH4 plus 2 moles of O2. I'm going to do a little multiplication symbol there because I forgot it. Okay. The reason I'm putting a multiplication symbol is because we have different numbers of moles for each of all of these things. For CO2, we had 1 mole. For H2O, we had 2 moles. So whenever I start using my enthalpies of formations, I'm only going to need 1 of them for CO2, but I'm going to need 2 of them for my H2O since I've got 2 moles of it. So we're going to start plugging things in down here on the next row. We're going to have products again. Here's my products. Oops, I meant to do a highlighter there. There's my products. In my products category, I had 1 CO2. So I'm going to use 1, but where I have CO2 placed right now, I'm going to put in the enthalpy of formation for CO2, which is right there, that negative 393.51. It was negative 393.51 because it takes negative 393.51 joules to form CO2. Which is kind of weird because it's a negative number, but it'll be all right. And then I've got to do my water product. For water, I've got 2 of those, 2 H2Os, and I'm going to have to use this line here for H2O. H2O is formed using negative 241.82 kilojoules per mole. So I'm multiplying that by my number of moles to get my total for H2O. Okay, so that's my product side. On the reactant side, I'm going to do the same thing. I'm going to start with CH4. I've got 1 mole of CH4 that I'm using. CH4 has an enthalpy of formation of negative 74.8. And then I've also got O2. Now, O2 has 2 moles, but O2 is a little bit of a special case here. If you remember from way back when we were talking about the periodic table, oxygen is what's called a diatomic element. So it always exists naturally in pairs, always O2s, not just O's. And anytime you've got something existing in its natural state like that, which O2 is, those diatomic molecules, they have 2 of them connected. Anytime it exists in that state, its enthalpy of formation is 0 kilojoules per mole. So I'm going to have a 0 there on that one. That's kind of a special case. And now we've just got a lot of number crunching to do. So this is all multiplication and addition. I know you guys know how to do that. But we're going to start with the products. So what you need to do is add up just the products section. So we've got 1 times 393.51 plus 2 times negative 241.82. If you go type that into a calculator, for the products, you're going to have negative 877.15, and that's going to be for our products. And then we're going to do the same thing for the reactants. The reactants are pretty easy. We've got 1 times negative 74.8, which is negative 74.8, plus 2 times 0, and 2 times 0 is 0. So all we have over here in the reactants is negative 74.8. But here's where people go wrong. That's on this subtraction here, okay? So you're really doing, in this equation, negative 877.15 minus negative 74.8. That minus a negative is really going to turn into a positive, which is negative 877.15 plus 74.8. So there's several ways that you can handle this. Either you can know that your minus and negative is going to turn to a positive, or you can type it into a calculator using the minus button and the negative button, or you can use parentheses around stuff in your calculator as well. But any way you go about it, what you should get out of that is negative 802.35 kilojoules per mole. That's your unit on your delta H, kilojoules per mole. That's how many kilojoules per mole would be released or absorbed in the reaction. Now, since we got a negative number, we know that our system is losing energy. Negative means it's losing energy, okay? Now, when your system loses energy, it releases it out into the surroundings because that energy has to go somewhere. It can't just be destroyed because that's the conservation of energy. So if it's going out to the surroundings, it's feeling really hot and it is exiting the system. That means this is going to be exothermic because that energy is leaving. Anytime you've got a negative value there, that's going to mean exothermic. Now we've got one more example on this page, or on the next page, sorry. Example number 2, we're going to do this particular reaction. It'll be a little bit faster. We won't break it down quite as much. So we start off the same way by looking at the products. The products that we have here, or really it's only one product, is H2O. And we've got 2 H2Os, okay? And then for our reactants, we have H2 and O2, 2 H2s and 1 O2. All right, now when we plug stuff in here, we're going to use our coefficients. So we're using 2 H2s. We got to go look up H2. It's up here. It's negative 241.82. And then we've got our reactants side, which is super easy because H2 has 0 kilojoules per mole as well as O2 having 0 kilojoules per mole. So that side is really. So now all we need to do is 2 times negative 241.82. Got to whip out my calculator for that one. And that is going to get us negative 483.64. And then from that, we are going to subtract 2 times 0 plus 1 times 0, which is 0. So for that one, we're going to get negative 483.64. And again, we have a negative number. Negative means that our energy is leaving the system. And since it's leaving the system, it's being subtracted from the system, it's exiting. That is, once again, exothermic. All right, guys, well, that is it on the enthalpies. Enthalpies of formation, finding the enthalpy of a reaction. The things that you really have to be careful of on this are using your coefficients. You got to make sure you use those and watching out for all of those negatives along the way because they can trip you up if you're not careful with them. Okay, so I think that gives you just a practice to work on today, so better get after that. I'll see you around.